Okay, welcome again. Tools of Geometry, Unit 1. We have gone over all the units, or actually all the chapters of Unit 1. And these are the things that you need to know for the test, okay? These are the things. You need to know the vocabulary that is listed here. Make sure that you go over everything on this list. And do you know exactly by memory what it is, okay? That you know how to define it, that you can draw a picture of it. We've gone over all the vocabulary. It's pretty simple, but make sure that you know it. Besides that, we need to know, let's see, let's go to the second page here. Okay, it says at a point. See, if you know the vocabulary, then everything else is very easy. See, add a point C to the picture so that it is collinear with points A and B. Collinear means what? It means that they are on the same line. So if I am to add a point, I need to add a point so that it is collinear. It's a point C. So I'm going to add a point right here, and I'm going to call that point C. There you go. And now A, C, and B are all collinear. Then add point D so that it is coplanar with plane M. Well, first you need to know where is plane M. Well, plane M is this one that is vertical. So just to add a point D, I'm just going to add a point right here, and I'm going to call it plane D. And this is point D is coplanar with plane M. So plane M is actually in plane M, right? Now let's look over here. Use picture to answer the following. Name 3 lines that intersect at point T. So here is point T. Now which are the 3 lines? Well, we have this one, we have this one, and we have the one that is not on the plane, that comes from above the plane, intersects it at point T, and then goes under the plane, right? So those lines would be line. Remember, lines can be named by 2 points on the line. So this line right here, we can name it line LX. So I'm going to name that LX, and that is a line with a double arrow. Now, what other line? Well, line TV. See this line right here? There are 2 points, lines TV. So T, V, and the double arrow lines on top of it. And then what's the other line? The one that comes from above. So that would be line ST. Line ST. Okay. Okay, it says here, name 2 opposite rays. Well, 2 opposite rays that I could name here would be ray TL. Ray TL. And then this one going that way, opposite, it would have to start at T and goes the opposite way, so it would be TX, ray TX. So there are the 2 opposite rays. Are the only 2 that I could name here on this picture. Draw line XV. Well, line XV has to start where? It has to, the end point is X, so it starts here and it goes through V. So I'm just gonna, to make it straight, I'm gonna pull a line right here. I'm gonna start at X and go through V right there. And then I'm going to make that line a little bit thinner so that it looks even with the rest. There we go. So that's my ray XV. So I drew ray XV on the picture. What is the intersection of plane Z? Plane Z is this plane right here, and plane STL. Well, to look at plane STL, remember that a plane is denoted by 3 non-collinear points. Here is point S, here is point T, and here is point L. So notice we have a plane that comes, it's like a triangle that comes from above. And it intersects the plane at this line right here. So that would be what? Remember that the intersection of 2 planes, it's always a line. So it has to be a line. So that would be line LT or line TL or line LX. That would be. So you could say line TL is good. Line TL, you could name it by 2 points. So I'm just going to use these 2 points. T and L, and then it will be the line, because this will go on forever, and so does this. Remember, even though we draw edges here, planes have no edges. The other thing you need to know is how to find the midpoint and the distance between each pair of points. So we're given a coordinate. Remember that the midpoint formula is x in point 1 plus x in point 2, and that will give me the x coordinate divided by 2, and then y in point 1 plus y in point 2 divided by 2. That would give me the midpoint. So to do the midpoint, I'm just going to say, well, the midpoint is given by -2 plus the other x is -2 divided by 2. That will give me the x coordinate, comma, and then I go to the y-axis, 2 plus 5 divided by 2. Okay, -2 plus -2, that is -4. -4 divided by 2, and 7 divided by 2. Well, -4 divided by 2, remember to simplify that. That would be what? -4 divided by 2, that would be -2. So then my answer is -2 and 7/2. And that would be my final answer for the midpoint. However, for the distance formula, I gave you the formula before. Here we go. This is the square root of x in point 2 minus x in point 1 square plus y in point 2 minus y in point 1 square. Okay, that's the formula. So I'm going to use that. Here is x and y. X and y. This is 0.1 and 0.2. So to use that, the distance is equal the square root of what? The x in 0.2, that would be -2 minus -2. So when it's minus negative, it's plus 2, right? Square plus, there's the plus, y in 0.2, which is 5, minus the y in 0.1, which is 2, and then square. Well, -2 plus 2, that's 0, and 0 square is just 0, so this practically cancels out. And then it leaves me with 5 minus 2, which is 3 square. Well, 3 square is what? Is the square root of 9, and the square root of 9 is just 3, because that's a perfect square. So the distance would be 3. Okay, so here is my midpoint, and here is my distance. Okay, so I do that so that teacher knows that those are my answers for midpoint and distance. How about here? Well, here you could use the graph. The graph, if I take this point graphically, I take it here. I could use the formulas. I just need the coordinates, right? And the coordinates are easy because this is 3 and 3, because this is 3 and 3. Right? And this is 5 and -3. This is 5, -3. So once you have the coordinates, you could apply this right here, right? But if it's graph, I'm just gonna take this to the graph right here. So I'm gonna move this point, boom, 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 to the y-axis, or you could move it to the x-axis if you like. It doesn't matter. I would go with the even one. So I'm gonna move it here. So notice I moved this point right here. This point's right here. I'm showing you how to do it graphically, right? And to the top, I have 3. To the bottom, I have 3. So this is my midpoint. So right there is my midpoint. I already finished, 1, 2, 3, 4, 5, 6. So 3 is halfway there. So this is the midpoint right there. So now I move that back to the line, or the line segment in this case. So this is my midpoint. And my midpoint would be at what? At 4, 0. So the midpoint equals 4, 0. Wow. And what is the distance? Well, the distance Notice that I'm gonna make like a little triangle right here. And then I'm gonna use the Pythagorean theorem. Or you could just use the distance formula. Either way is fine, okay? If this is 2, 1, 2, and this is 1, 2, 3, 4, 5, 6, this is 6. So notice basically that I could use this Pythagorean theorem. I could use the distance formula. I already know that the difference in the x's is 2. The difference of the y is 6. So basically the distance is equal 2 squared plus 6 squared. See that? Because this is basically the difference is here, 2, and the difference here is here, which is 6. See? So now I just go and solve that. That's 4 plus 6 squared is 36. 36 plus 4, that is 40. So remember, if we want the actual distance in using the basically simplifying this would be 4 times 10, right? This would be 4 times 10. And the square root of 4 is 2. And then the square root of 10, you just leave it like that because that is an irrational number. So that is the distance. The distance is 2 square root of 10. Basically. And there you are. Okay. Let's move on. Okay, another thing you need to know is how to find the measurement, and the way it's going to be tested is this way that I'm showing you here. Yeah, I'm going to give you a drawing of a protractor and an angle, and basically what you want to do is either pick the outer or the inner, it doesn't matter, and what you want to do is put the coordinates there. So the absolute value, remember the protractor postulate, this is 130 minus the difference, and then you go to here and notice this is 29. This is 29 because that's 10, 20, 25, 29. The absolute value of that would be the measurement of this angle. So 130 minus 29 equals the absolute value of 101, which is 101 degrees. And that's how easy that is. Here's another example. So this one is what, about 150. I'm going to put it at 150. So the absolute value of 150 minus, and this is 55. So what is 150 minus 55? Well, that is the absolute value of 95, which is 95. So that's 95 degrees. So that's how simple that is. Now, if you use the outer, that's when it's going to give you a negative number. Remember, it's always positive. That's why you use the absolute value. Now, let's go to the next. Here is another way that you're going to be tested, how to use the knowledge that you're supposed to have acquired here in the unit, right? So the measurement of angle UTS is 150 degrees. So the measurement of angle UTS, which is this whole angle right here, is 150 degrees. The measurement, I'm going to put it right there, is 150. That's the whole thing. Now let me change colors just so that we could differentiate. The measurement of angle UTN right here, that's 36 degrees. Okay, so here I'm going to be applying the angle addition postulate. I know that this angle right here plus this angle right here is going to give me the two reds, is going to give me this green one right here, right? So that means that the measurement of angle UTN plus the measurement of angle NTS equals the measurement of angle UTS. What is the question? Find the measurement of angle NTS. That's the question right here. That's the question. So UTN is given, or UTN is given at 36 degrees right here, 36. So I'm going to substitute that. 36 plus the question mark, right? That's NTS. That's what I'm looking for. Equals UTS, which is 150. So this is like if you had X over here. So I'm just going to subtract 36. So the question mark is 150 minus 36. Well, 150 minus 36. All I have to do is 10 minus 6. Remember that I'm left with 4 over here. This one becomes 10. 10 minus 6 is 4. 4 minus 3 is 1. And then I have 114. So the measurement of angle NTS, which is just this part right here, I'm gonna put it in blue, just this right here, that is 114 degrees. So I'm gonna answer the question, measurement of angle NTS equals 114 degrees, and that's the answer to the question. Pretty simple. Okay, moving on. So we have a few of these to practice. I gave you a few of these on the review to practice. Here we're given that the measurement of angle ABJ right here is 11x plus 1. So this one is 11x plus 1. That's this one right here. And then ABC is 160. ABC is the whole thing. So I'm going to change colors. ABC is this angle right there. That's 160 degrees. And then the measurement of JBC, which is, I'm going to put it in red. JBC right there. That one is 6x plus 6. So 6x plus 6. So notice the red one plus the blue one is going to give me the green one, right? So I'm going to write it here. The measurement of ABJ, measurement of angle ABJ, plus the measurement of angle JBC should give me the measurement, or will give me the measurement of angle ABC, which is the big one. Okay, now it's a matter of substitution. Well, ABJ is 11x plus 1 plus JBC, I look for JBC, is 6x plus 6 equals angle ABC, or the measurement of angle ABC, which is 160 degrees. All right, so now combine like terms. So notice 11x plus 6x, that's what, 17x. 1 plus 6, that's 7, equals 160 degrees. So subtract 7 from both sides, so you have 17x equal 160 minus 7. So that is 153. Okay, so now all you have to do is x is equal 153 divided by 17. Go to the calculator. 153 divided by 17. The answer for x is 9. So x equals 9. What is the question? Find x. So what is my answer? X is 9. See, always go back and see what is the question that they're asking. Don't make that mistake. Students make that mistake often. Sorry. Here is another question. It says find the measurement of MLI. Here is MLI right here. That's what I'm looking for. If the measurement of MLK MLK is the whole thing. So let me change color. This whole thing is MLK. That's 154. The measurement of MLI is 3x plus 13. So let's go back to red. This is 3x plus 13. And then the measurement of ILK, I'm going to put that in green. ILK is this one right here. That's 8 plus 16x. 8 plus. Okay, so the red plus the green is going to give me the blue. So I'm going to go here. I'm going to write it. The measurement of MLI. Plus the measurement of ILK. Angle ILK. Equals the measurement of angle MLK. So that is my angle addition postulate. I'm going to apply it. So the measurement of MLI is 3x plus 13. So MLI is in red, 3x plus 13. Plus the measurement of ILK. ILK is 8 plus 16x. Equals the measurement of angle MLK, which is 154. See, once you set this correctly, this is your angle addition postulate, and you substitute, the equation is already formed for you. Now all is left is solve the equation. So 16 plus 3x is 19x. Then you have 13 plus 8, that's 21, equals 154. Okay, so that means that 19x equals 154 minus 21. Remember, if you change sides, you have to change the sign. Notice it's positive on this side of the equal sign. When I put it on the other side of the equal sign, it becomes negative. So I have that 19x is equal 4 minus 1 is 3, 5 minus 2 is 3, so that is 133. So now all I have to do is divide 133 divided by 19. Okay, at this point I could just go to the calculator. 133, too many threes, divided by 19. Enter, and that is 7. So x is 7. X equals 7. Go back. What is the question? Find the measurement of MLI. So the question is not find x. The question is find the measurement of MLI, angle MLI. So I'm going to go to MLI. The measurement of angle MLI given from them is 3x plus 13. So all I have to do now is plug in that 7. So that means 3 times x, x is 7, so times 7 plus 13. 3 times 7 is 21. 21 plus 10 is 31. 31 and 3 is 34, right? So plus 13, that means this is 34 degrees. So the measurement of angle MLI is 34 degrees, and I underline my answer. There you go. Not a problem. Okay, here is one more. I got the measurement of angle CQP. ZQP is this angle right here. That would be 5x minus 5. So 5x minus 5. That's in green right there. Then the measurement of angle RQP. A little low on the pad there. Okay, the measurement of angle RQP. That's the whole thing. So I'm going to change colors there, and I'm going to say, well, the whole thing right there, RQP, that's 20x. I'm going to put it up here. And then in red, I'm going to find the measurement of RQZ, which is this right here. RQC is 125 degrees. Okay, so find the measurement of RQP. Here is my question. So let's do it. I'm going to write it. I'm going to say the measurement of angle RQZ plus the measurement of angle CQP must equal the measurement of angle RQP. Once I have that, I just substitute. ZQP is 5x minus 5. RQZ, I'm looking for that. That's 125. So that's 125 plus ZQP is 5x minus 5 equals RQP, which is 20x. Okay, now I start solving. What is 125 minus 5? Well, that's 120 plus 5x equals 20x. Now I'm going to take this 5x, move it to the other side. Remember, I have to change the sign. So 120 is equal 20x minus 5x. That's 15x. Now I divide by 15 on both sides. So 120 divided by 15 equals x. Okay, go to the calculator. 120, 20 divided by 15, that's 8. So now I know that x equals 8. Once I have that, it doesn't say find x, it says find the measurement of RQP. So I'm going to go to RQP. RQP is 20x. So that means RQP, the measurement of angle RQP, equals 20x, which is 20 times 8, which is 160. 2 times 8 is 16. Put that 0 there. So that is the measurement of angle RQP. There we go. That answered that question. Pretty neat. Another thing you need to be able to do is read diagrams. So list all information given by the marks on the diagram. Okay, so notice I have 2 arcs here, 2 arcs here. So that means angle R must be congruent to angle U. Another thing I know is that segment RT is congruent to segment TU. That means that T is the midpoint of segment RU. So all this is implied in this diagram. How about this diagram right here? Well, I could see that segment EF is congruent. Let me fix that right. Awful. Is congruent to segment FG. Another thing I could say is that segment DW is congruent to segment VH. Another thing I could say is that angle ECF is congruent to angle FCG. that's given. Because of that, I could say that the ray CF is the angle bisector. Because these two are congruent, that means it's cut set in half, is the angle bisector of angle ECG. Look at all the things that I could say because of that. Pretty neat. Another thing you must be able to do is name the relationship of the angle pairs. Like for example, you gotta be able to say if they're adjacent, complementary, linear pairs, supplementary, or vertical angles, okay? And you want to use the most precise, okay? So like for examples, A and B, these are what? These are vertical angles. Okay, vertical angles. Angles A and B over here, I cannot say they're supplementary because this is not a straight line, but I could say they are what? They are adjacent angles. So adjacent angles. How about this one? This one I could say that they are a linear pair. That means they're supplementary. So they are a linear pair. However, this one, I could say that they are what? They add up to 90 degrees, and I know that because of these right angles. So these two, whatever they are complementary angles. So I don't know if use one P or two P's there. Complementary. Complementary angles, okay? Find the measure of angle B. Well, here you have to be able to use what you know. These are complementary angles, so they must add up to 90. So 90 minus 31 should give me the measurement of angle B. In this case, 10 minus 1 is 9, and 8 minus 3 is 5. So this must be angle B equals 59 degrees. How about this one? Well, the whole thing must equal 360. I already have two angles right here. I just need this one. So 294 plus 42. 4 and 2, that's 13, that's 336. Now, to complete the whole circle, has to add up to 360. To 360 minus 336 degrees, that's 10 minus 6 is 4. 5 minus 3 is 2. So this angle B is 24 degrees. Pretty simple. Well, here we need to use the geometric knowledge and use our algebraic knowledge. It says find the value of x. Well, I know that these two are a linear pair, so they must be supplementary. That means they must add up to what? 180. So 3x plus 2 plus 73 must equal 180 degrees. So this angle plus this angle must equal 180, and that's what I put here, right? So 3x plus 73 plus 2, that's 75, equals 180 degrees. That means 3x equals 180 minus 75, that's 105 degrees. X is equal 105 divided by 3. Go to the calculator, make it easy. So 105 divided by 3, and that's 35. So that means x equals 35. Okay, then we have these two. Well, you need to know how you're gonna set it up by understanding that these two are vertical angles. Vertical angles are always what? They're always congruent. Therefore, this angle must be equal to this angle, or the measurement, you know, for x plus 2. Okay, so take away 2 from both sides, so that means this becomes 40 equals 4x. X is 40 divided by 4, well, that means x equals 10. Done. Pretty simple. Let's see what else we have. Okay, given I is the midpoint. Remember, if I is the midpoint, that means this must be congruent to this one. So this segment is the midpoint, cuts the segment into 2 congruent segments. Is given is WI is 5x minus 12. And IN is 2x plus 6. Question, find x. Well, I know that if these two are congruent, that means WI must be equal to IN. That means 5x minus 12 must be equal to 2x plus 6. Subtract 2x, so 5 minus 2 is 3x. Add 12 equals 12 plus 6, that's 18. Then divide this by 3, so x equals 6. So x is 6, that's the first answer. Then find WI. So WI is equal 5x minus 12, or 5 times 6 minus 12. This is 30 minus 12, which is 18. So WI must be 18. And there you are. Simple. As long as you know your geometry, then everything else works perfect. Given WN. WN is the whole measurement from here all the way to here. And that is 6x plus 3. So that's from there to there, the whole segment. WI is 12. And IN is 5x minus 4. Well, here you have the segment addition postulate. WI plus IN equals WN. WI is 12 plus 5x minus 4 equals 6x plus 3. 12 minus 4, we have 8 plus 5x equals 6x plus 3. It benefits me to move that 5x to that side because 6 minus 5 is 1. So I would have x. See, 6x minus 5x is x. Then take this 3, move it to this side. 8 minus 3 is 5. So now I have the answer for x. X equals 5. And then find IN. IN is 5x minus 4. So 5x minus 4 is the same as 5 times 5 minus 4. This is IN. That means that this is equal to 25 minus 4. And 25 minus 4 is just 21. So IN equals 21. And here is the answer. See? All right, is there anything else? Let's see. Applications. Okay, let's look at this. Graph the point A at 4, 7. 4, 7. So that's point A. Then points B, it's at 0, 0. That's point B. And then point C is at 8, 1. That's point C. Okay, connect the points in order to make triangle ABC. So let's connect those points. Let's connect those points. Got that? I got that. And I got that one. Okay, find the distance from B to A. The distance from B to A, notice if I make the triangle here, I'm gonna make me my triangle. So I'm going to use that Pythagorean theorem. It's easier, right? Or the distance formula, but I'm going to use it because it's derived from the Pythagorean theorem. Notice I have 4 here. 1, 2, 3, 4. That's 4. Here I have 7 because from 0 to 7. So now I know that this distance is the square root of 7 squared plus 4 squared, which is 49 plus 16, which is 6 plus 9, that's 5, 5, 6. That's the square root of 65. So the square root of 65, okay, so I have that. That's the square root of 65. So BA is the square root of 65. Given that BC equals the square root of 65, so BC is the square root of 65 as well. So this is the square root of 65. This is the square root of 65. What is true about BA and BC? Well, that means that BA is equal to BC because we're talking about, it's not congruent. It's equal because you see there is no segment on top. So the distance from B to A is the same as the distance from B to C. So now that I have that, find the midpoint of AC. The midpoint of AC, well, let's look at that. If I bring this here, let's take another color so you can see this. If I bring this point here, I'm going to do it graphically, right there. And I bring this point C over here. So I'm here and here. So how many I have? 1, 2, 3, 4, 5, 6. So notice all I have to do is cut it in half. 6 divided by 2 is 3. 1, 2, 3. So I'm going to go to that 4. And in that 4, which is my midpoint here, I'm going to go straight to that line. And look, it's right there. That is at 6, 4. So the midpoint, find the midpoint of AC is 6, 4. Plot on graph as point D. So this must be point D. There we go. Is there anything else? Okay, draw BD on the graph, or ray BD on the graph. So I'm going to draw ray BD. So let's look at this. Ray would be this one, and it would be that way right there. Okay, let's make that thinner so it looks better. There we go. So now I have ray BD. All right. So on the graph, BD is the angle bisector of, or ray BD is the angle bisector of angle ABC. ABC. That means that this angle and this angle must be congruent. Mark the picture to show this. I just did. All right. Anything else? Nope. That's it. Hey, that was pretty neat. Not that hard. Not that hard. Let's look at something else here. Okay, proof. Label the picture and fill in the missing reasons in the 2-column proof. Okay, so given that the measurement of CKJ is 6x and LKJ, this whole thing up here is 9x minus 1. That's the whole thing. And then LKC, this is 20. Okay, prove that x equals 7. So all these are given. So I'm going to put here given for the reason. It says the measurement of CKJ, which is this one right here, plus the measurement of LKC is equal to the measurement of LKJ. Well, that is the angle addition postulate. All right, so 6x plus 20, 6x plus 20, well, CKJ is 6x, so this is substitution. See, LKC is 20, and LKJ is 9x minus 1. This is just substitution, so I'm gonna put that there, substitution. Okay, so from there, what happened? Notice that it changed from 6x plus 20 equals 9x minus 1. Here is my 9x, but it says minus 21. So what they did is they took this 20 and they subtracted 20 from both sides. So there is no longer the 20 here, and when you subtract, it gives you negative 21. So this is the subtraction property of equality. So subtraction property, I'm just going to abbreviate, of equality. All right, so from here, what happened? So notice the 6x changed to negative 3x, so I must have subtracted 9x. So 6x minus 9x is negative 3x equals negative 21. So I still use subtraction property of equality again. Subtraction property of equality. And then from there, I divided by negative 3 on both sides, so that is the division property of equality. And we are done. We're done. Ooh, I thought we were done. We got one more. Geometric shape. Mr. Sullivan's dream home is in the shape of a pentagon. Help him answer the questions below. Mark the pictures with the following. Segment HY, so we look for segment HY right here, is congruent to segment US. So I'm just going to go like this and put 3 marks because that's pretty long. And I'm going to put 3 marks here. So these 2 segments are congruent. Segment OE is the bisector of segment HU. So look for segment HU and look for segment OE. Well, OE is the bisector, so that means it's cutting HU in half. So I'm just gonna put a tick mark and a tick mark because this one is cutting HU in half. Angle HMO is a right angle. Angle HMO is a right angle. So I'm gonna mark it right here. That's a right angle. E is the midpoint of segment YA. So point E is the midpoint of segment YS. So I'm just gonna put 1 1 and I'm gonna fix this and put 2 2 because it's longer, right? So it's nice to keep it that way. Then we have that OH is congruent to OU. So I'm gonna put 3 marks here. And I'm gonna put 3 marks here because this is longer, and then I'm gonna put 1 more mark here. So this is the longest. See, so 1 1 because it's the shortest. 2 2 3 3 4 4. I do not know how much they measure, but I know that they are congruent. And then angle OHU, where is, oh, here it is. Angle OHU is congruent to angle MUO. So this angle is congruent to this angle. All right, use the info to find the following. Given that YE is 4x plus 3. So YE right here, this is 4x plus 3. And YS is 39. YS from here to here, that's 39. Well, I know if this is 4x plus 3, this is also 4x plus 3, right? So twice this is 39. So I'm gonna say, well, that means that twice YE is gonna equal YS. So that means twice of 4x plus 3 must equal 39. 2 times 4, that's 8x. 2 times 3, that's 6. equals 39. Subtract 6 from both sides, so 8x equals 33. X is equal 33 divided by 8, and you could leave it as that, okay, because it doesn't say to round it to anything, and this doesn't simplify any longer. So find x. X is 33/8. Okay, 33/8. Given that the measurement of OHU right here, that's 4x plus 3, and the measurement of MUO, that's 5x minus 9, then find x and find the measurement of MUO. So find x and find the measurement of MUO. I'm going to work them over here. Since they are both congruent, that means they must equal each other. So I'm going to say that 4x plus 3 equals 5x minus 9. Well, I'm start moving things around. It's easier if I move that 4x to that side, because 5x minus 4x is x. And then 3 plus 9 is what? 12. So that means x is 12. So I have my first answer. Find x. X is 12. Then the next question is find MUO. Well, MUO is 5x minus 9. That's the measurement of MUO. Or 5 times 12 minus 9. That's 60 minus 9. So that's 51 degrees. So the measurement of angle MUO equals 51 degrees. And I think that is it. Yep, that is it, guys. And that's all you need to know for your test. So make sure you study. So let's get going.